base increases the number of OH minuses, or the hydroxides. We'll talk about hydronium a little bit later on. That's H3 3O with a plus charge there. So you have an empty canvas now. You have a blank canvas. So what I want you to do is try and visualize this, and I'm gonna keep telling you, and then I'll reveal what I have, compare with what you have, and we'll see what you came up with. Don't do this in something that's like, just try to do it to get it right. Think about what we're doing here. So first, here's a line between here. This is going to be your pH scale. Let's start right smack dab here in the middle, right at 7. Leave space to write stuff on the left and stuff to write things on the right. So we got a 7 here. If this were the pH scale, and yes, you should be doing this at your seat, we'll see what you come up with. All right? I do this with every level of bio to make them think through it, from like team to honors to AP, to think through it, don't rush through it. Try and visualize what this scale really means and how it relates to hydroxide, hydrogen ion, and water. Because remember, there's all those 3 players are involved. Okay, so if we got a 7 there, we're not going to number 0 to 14. We're not going to write the whole scale. So there's 7, right? So to the right of it, well, how would I label that? Someone said it? Neutral. So you got your 7 here. Now start imagining this picture here. Neutral. Kind of like being like Michelangelo when he would envision, doing his sculpture. He just looked at it. He could see it already. So let's see if we can see this in this empty canvas here. All right. So neutral. Okay. So I got 7. I got neutral. And let's do this. In the same line right here, let's write H plus equals what? OH minus. So we got a line. So see if you can visualize this. You got a 7. You've labeled it neutral. Now you have a little formula. H plus equals OH minus. All right. So if we have a 7 there, we can go above or below the neutral pH, right? So 1 below is 6, 1 above is 8, so let's add that. Put a 7, have an 8, have a 6. All right. So now, what are the extremes of the pH scale? We've been clustered right next to the neutral pH. What are the extremes? What? 0 and 14. So we got our 8, our 7, our 6. Skip a little space and put 0. Go up a little space and write 14. Again, if you're struggling a little with this, that's fine. You'll see the final product. This has no bearing on how you're going to do on the test. But I want you to think through this, not just blindly copy a scale I'm going to give you. Okay. So now, if we did 7 and we labeled it neutral, what can we do with these ones and these ones? Well, we're going to say that for the end. All right. So let's just go 0 to right underneath 7. Draw a little bracket and label that what? All right, acid. Those you want to add in strong and weak, we're going to do that on the left side of this. Okay, so now we got, this is what I'm seeing on this blank canvas. I see a 7, I see an 8, a 6. I go down to here to 0, and I got a bracket, and I've labeled this acid. So what is the other side of this? Okay, so make a bracket, say just above 7, all the way up to 14, and then label that what? Base. All right, we got our acid and all base. Okay. Did we write a formula over here with 7? Yeah, we did. We said H plus equals OH minus. So over here in the acids, let's write the difference between this one and the neutral. When we go below 7, or when we have a pH that's lower than 7, it's indicative of an acid, which is it more H's or more H minus? OH minus. I can't hear you. Are you going to speak up so I can hear you?
For acid, would be like more H's
Okay, so let's do this, right? H plus, what's the symbol should I use for greater than? You know that one? H plus greater than OH minus for the acids. Oh, you already see it up here? I see it. You? Okay, so now the base. What do we do there? There's two ways to write it. Now, there, what did you say? All right, so you can OH what? OH minus. Greater than or less than? All right, so OH minus greater than H. Now, I did the other way, which is fine, and either way is correct, because you can also write H plus less than OH minus. Okay, so now over here, on the left side of this, let's talk about strengths and weaknesses. The closer you are to neutral, the weaker it is. The farther from neutral, the stronger it is. So, say just below 7, what would I label that? Weak acid. Now, we're not going to get into, oh, well, this one's stronger than this, that. We're just going to label the kind of the general area. We haven't labeled the whole pH scale. We can give you specifics, but let's just visualize this. Visualize this. Okay, so above 7, just above 7, weak base. What's left? We got weak. What about strong? So at the top, towards the top, say you're 12 or above, and like less than, or between 1 and lower, or maybe 2, okay? Then so at those, we got our strong base, strong acid. Are there any questions? So let's see how close you came to my visualization. Let's see. Did you get something that looks like this? I have more numbers here. Don't worry about that. I only told you to write these. Okay? So the thing about it is, yes, I wrote less than because I tried to fixate on having hydrogen here and oxygen hydroxide on this side, but that's fine. All right, so think about it. An acid, when you add an acid, it's going to lower the pH. It's going to increase because the pH scale is a logarithmic scale. It's actually minus the P scale. It's actually, it's referred to as a P scale. So it's actually minus the log of the hydrogen ion concentration. All right, and then it has to get into, understanding the ion product constant of water, but we're not going to get into that. When you take chemistry next year, you'll have to know that. So if I increase these, I have an acid. If I increase this, I have a base. Substances that mix with water and they dissociate out, when they do that, they increase the acid concentration or they increase the base concentration, depending on whether it's sodium hydroxide, it's going to add hydroxides to that water. If it's like hydrochloric acid, it's going to add hydrogen ion. So, are there any questions? All right, we're done.